A great encounter on the planet Mars. We give you the most cordial welcome to this new documentary. If it is the first time, I introduce myself. I am the Engineer Hiddekel Morrison and I appreciate you decide to see this educational content, where we will detail and explain this historic great encounter on the planet Mars, the most impressive, largest and most studied rock on the red planet. Join me in this new educational adventure of a broad historical account with relevant information about the exploration of the planet Mars, from the perspective of an engineer. Let's start. This great encounter on Mars was made possible by the Mars Pathfinder exploration mission, which launched on December 4, 1996 and landed in the so-called Ares Valleys on July 4, 1997. This mission was designed as a technology demonstration of a new way to deliver an instrumented lander and the first robotic vehicle to the surface of the red planet. The Pathfinder mission not only achieved this goal, but also returned an unprecedented amount of historical data and outlasted its primary design life. Both the lander and the 23-pound Rover robot carried technology instruments for science observations and to provide engineering data on new technologies being demonstrated. Scientific instruments were included to analyze the Martian atmosphere, climate, geology, and the composition of its rocks and soils. The Mars Pathfinder mission used an innovative method to enter the Martian atmosphere directly, aided by a parachute to slow its descent through the thin Martian atmosphere and a giant system of airbags to cushion the impact. When it reached the surface, this first robot rover to reach the planet Mars achieved a great encounter that we detail below. But first, I ask you to support us by liking this video, sharing this video with your contacts, and subscribing to this channel, turning on notifications, so with your support, we can continue to frequently generate interesting documentaries on aerospace technology and the universe. Thank you for contributing to the creation of educational content. Science is the father of knowledge, but opinions are what breed ignorance. Hippocrates. This is a great encounter, a historic encounter where the first robot rover to reach the planet Mars meets the first large rock identified on Mars that is not only the most and best photographed stone on Mars. This rock was the first on Mars to be found to be made of basalt, which suggests previous volcanic activity in the region, since basalt is an igneous rock, meaning from fire. Also thanks to this encounter, the robot's sensors determined the smoothness of the surface, which suggests the past existence of water in that region. This first robotic rover on Mars was named the Sojourner rover, and it analyzed this large rock in detail with its alpha proton X-ray spectrometer to determine the rock's internal composition. From landing to the last data transmission on September 27, 1997, the Mars Pathfinder mission returned 2.3 billion bits of information to planet Earth, including more than 16,500 images from the lander and 550 images from the rover, as well as more of 15 chemical analyses of rocks and soil and extensive data on winds and other meteorological factors. Findings from investigations carried out by science instruments on both the lander and the rover suggest that Mars was at a hot and humid time in its past. The lander for this Mars Pathfinder mission was formally named the Carl Sagan Memorial Station, and the rover, named Sojourner as noted, was named after American civil rights advocate Sojourner Truth. The technologies and scientific instruments of the Mars Pathfinder mission were decisive. The robot arrived equipped with an alpha proton X-ray spectrometer to determine the elemental composition of rocks and soils. 3 cameras that provided them with images of the surrounding terrain for geological studies and documented the performance and operating environment of the Pathfinder mission technologies. An atmospheric structure/meteorology package instrument that measured the Martian atmosphere during Pathfinder's descent to the surface and provided meteorological measurements on the lander. With all these tools and technologies, as we reach its 25th anniversary, we can share some of the main scientific findings of the Mars Pathfinder mission. Rounded pebbles and cobblestones at the landing site, and other observations, suggested conglomerates that formed in flowing water during a warmer past when liquid water was stable. Radio tracking from Mars Pathfinder provided an accurate measurement of the lander's location and the rotational pole of Mars. Measurements suggested that the radius of the planet's central metallic core is greater than 1,300 kilometers but less than about 2,000 kilometers. Airborne dust is magnetic, and its characteristics suggest that the magnetic mineral is magnetite, a highly magnetic form of iron oxide, which may have freeze-dried into particles such as stain or cement. An active water cycle in the past may have leached iron from crustal materials. Dust devils were seen and frequently measured by temperature, wind, and pressure sensors. The observations suggested that these bursts are a mechanism for mixing dust in the atmosphere. Clouds of water ice were observed in the lower atmosphere in the early morning. And finally, abrupt temperature fluctuations were recorded in the morning, suggesting that the planet's surface warms the atmosphere, with convective heat rising up in small eddies. What do you think about the contributions of this historic great meeting on Mars, which reaches its 25th anniversary? I read them in the comments of this video. As usual, we appreciate you informing us. It is a real pleasure to be able to provide you with the main news, trends and developments about the most important aspects of aerospace technology and the universe, from the perspective of an engineer. I am the Engineer Hiddekel Morrison and I invite you to meet again in a future installment.